No, yeah, that's all good. So yeah, for the querying process, when a user submits a query, the query is then embedded to the to the to, sorry, the query is then embedded, and it's then kind of mapped on that plane, right? So if a user asks, for example, like, what is a baby cat called, right? We know that a baby cat is a kitten, so we expect the word kitten to be returned. So, what is the purpose of this, right? So, it allows precise matching and retrieval of relevant information. So, for example, if I have a document that talks about World War II, and I ask the language model like, "Hey, tell me about World War II," it will then go into it will then take my query, embed it, and then search the vector database for any relevant document, and it will find, oh, here's a document that's very close, and it's going to be the World War II document. So and that's going to be how RAG then pulls out relevant documented information to then give to the language model. So what's a vector database? So this is kind of something we went over briefly, but a vector database is used by RAG to store these vector embeddings. So if the vector embeddings, or so if the embedding model creates the points on the plane, you can imagine the vector database as being the plane itself. So, so it stores these embeddings, and like I mentioned earlier, it can be like words, sentences, images, videos, whatever, right? And it organizes these different vector embeddings based on the similarity, like I mentioned earlier, the cat and lion or dog and wolf thing. So an example process could be this. Let's say, for example, you tell ChatGPT, "Hey, my favorite color is green." And if you use ChatGPT, you may notice something every once in a while saying updating memory. That's RAG. So it's remembering what you're telling it. So if you say my favorite color is green, that is then stored into a vector database. It's then embedded and then stored into a vector database. And then if the user later asks, "Hey, what's my favorite color?" That query will then be embedded, and then it will search the vector database for the most relevant thing. It'll probably look for something like favorite color or something along those lines, and then it will find my favorite color is green. So then it will pull out that information you gave it earlier, give it to the language model, and the language model will be like, "Oh, your favorite color is green." So how exactly can we implement RAG? So it's actually fairly straightforward. So first you select a language model. Any language model can do. You can do small, large, whatever. And then you have to choose a vector database. There's many, many, many vector databases out there, but around the office we've been playing around with Milvis and oh, Sudan, can you remind me of the one you're using? I forget what it's called. Chroma?
I was in Chroma.
Yep. So Milvis and Chroma, and I think Postgres also has one, and Cassandra also has a vector database as well. So there's many, many vector databases out there, and Pinecone being probably the largest proprietary one. So after you choose a vector database, you then load your documents into the vector database. So it will embed your documents, and then you throw those embeddings into the vector database, and then you then query the database with like some user prompt or query, and then you retrieve the most relevant information. So, for example, like I mentioned earlier, the favorite color thing, it will retrieve the most relevant thing of like my favorite color is green, and then it's going to give it to the language model, and the language model is going to like either summarize or take out various information and just kind of respond back to what was found in the vector database. So here's kind of a small diagram as to how RAG works at a very high level. So first you have a user query and you have a knowledge base, and then the user query is then again queried into the vector database, and then both the most relevant information and your query is given to the language model to then generate a response. So then the retrieval process is a user generates a prompt, and then it creates an embedding, and then that embedding is then queried through the vector database, and it does a similarity search. It could be like cosine similarity or any other kind of metric, and then it retrieves the most relevant information to then give it to the language model, and then the language model generates the response. So here's kind of how the retrieval process itself works. So as you can see, the user query goes into the embedding model, which is then used to query the vector database through a similarity search, and then the knowledge base also looks through its set of vector embeddings, and then it does a similarity search between the user query and what the vector database has, and then it returns the top, let's say like five, like the top five most relevant documents. So now I'm going to give it back over to Siddhant, who will then go over the challenges of using RAG.
Hey guys, I'm back. So you guys won't miss me. Let's go to the next slide, please. So some of the main limitations of RAG, uh, because it's also a technological tool, every technology has its limitations. Here are some for RAG. First is the context window size. So mainly large language models, if you used, let's say ChatGPT, because it's the widely known one, if you ask it a very big question, after a point, it doesn't give you a response. It breaks in between, and then you see, hey, why does it break in between? I need the full response. It cannot print you a novel because a novel is a very big chunk of text, and it is definitely out of the range of context window size. There are different context window sizes for different LLMs. So it depends upon what LLM you are using. If your RAG, question, if your RAG document, if your RAG queries embeddings are more than the context window of the large language model, then the large language model will fail. It is bound to fail. That's why you choose a large language model with a bigger context window. Right now, what comes to my mind is Gemini. I think Gemini has 2 million. There are some open source ones as well who have 1 million context window. I think Claude yesterday launched Claude Enterprise, which has 500K. So yeah, next slide, please. Second is computation cost. It significantly increases your computation cost because there's a lot of other steps involved, like retrieving, storing, and parsing of information. You want the data that you gave in to be properly parsed and does not have any impurities in it. You have to pre-process the data. So it has a lot of steps before you can actually start working with RAG and LLMs together. So that can increase cost significantly. Next, please. And one of the major concerns among people is privacy, because let's suppose if I'm using a large language model API and I'm doing RAG against it, there's a chance that the company of whose API I'm using can use our data to train their models further, which we do not want, because our data could be private, it could be personal, and if someone else gets their hands on it, then it might lead us into trouble. So that's why you use open source large language models, so that you do not have a risk of this privacy trap that large companies, large proprietary companies lay out for people. That's how people are, like, companies are advancing LLMs, because they are collecting our data of whatever we are chatting with the large language model, and then they are retraining the large language model on the data that they have already received. Next, please. So let's go to the typical applications of where we can use RAG. Uh, Whatever information, if you want your large language model to be up to date, you can use RAG. If you have a very small data set that you want to train the large language model on, you can use RAG. If you have a company, if you have a firm, if you are doing just normal coding, you can use RAG to provide it with up-to-date context of documentations, files, and whatsoever. Next, please. And here comes the last part, conclusion. So large language model is here, will be there for a long period of time, unless and until OpenAI or some big companies develop big models that we do not have access to. And it reduces hallucinations. Hallucinations mean you do not get false responses or false positives whenever you search for something. It gives you improved accuracy. The accuracy that we got, me and Devin personally, in the lab is too good, and we love RAG. We love working with RAG. The outputs are reliable because you can see, because you can program it to tell you the document that it fetched the answer from. so that you have proper documentation and proper citations, efficient knowledge updates. We can put in knowledge of write this R into the large language model. So that's not a problem. And I think RAG has its application in almost every industry out there. So even if you are a developer in industry, business owner, or just a curious person, learning about RAG will definitely take you forward. Thank you so much, guys. And we just cited NVIDIA's blog because that's where we took some of our information from. That's where we took our learning from. So if you guys want, we'll be giving you this PPT if Tom agrees. And yeah, you guys can have a look at it. Thank you so much.
Yeah.
And this PowerPoint was made by throwing our paper that will be released after this talk into ChatGPT 4.0 and asking it to bulletize everything. So all these bullet points you see were all done by ChatGPT by summarizing our paper.
And that's not cheating, right? When you work in the AI lab, Devin. And so just to underscore what Devin just said, so we have a white paper on overview of retrieval augmented generation, and that'll be posted on LinkedIn immediately following this talk. But before we go into open questions, Devin, I know you've been doing a lot of work here in the lab on embedding models. Can you say a thing or two on some of that work that you've been doing with the embedding models?
Yeah, so right now I've been benchmarking some embedding models because I know that ChatGPT's embedding model, or OpenAI's embedding model has been, pretty popular, but it is proprietary and apparently it costs money. So so I've been looking into a lot of these open source embedding models, and oh boy, are there a lot of them. So I've been looking to for a project I'm working on, what embedding model is the most reliable for RAG, and what's the fastest, because embedding models are like language models since that they scale up in parameter size. So the higher the parameter size you go, the slower it's going to be. But conversely, it's also the more reliable it is. So I'm trying to benchmark these different local and open source embedding models to kind of strike a balance between, you know, reliability and speed. So I don't want something really, really, really fast, but also really bad at retrieval for RAG. And I also don't want something that's really, really good, which it's good, but it's also really slow, like 5 documents a second to embed. So yeah.
Now we have I'm not sure, Wendy mentioned, is there a way to solve the computation power issue? Yeah, that's a pretty tough question. Do you guys have anything you want to say about that?
So I feel like it's a combination. So it's not the issue with RAG itself, it's the technologies that go into RAG. So RAG, as we mentioned earlier, consists of an embedding model, a vector database, and a language model. So to solve the computation power issue, you need to find a vector database that is insanely fast and uses really good and really fast and really efficient similarity metrics. And like I was just mentioning earlier regarding the embedding models and them being like really good at retrieval, but also really fast. That's one of the things I'm looking at. And the next thing I do want to look at is the vector databases, comparing like Chroma and Milvus and some other open source ones like Postgres, to see like how fast they are and how efficient they are at retrieving documents. So it's not the issue with RAG itself that with the power computation. It's the issue with the whole stack.
Great, thanks, Devin. Are there any questions then from the audience? Any other questions? We had a few in chat, but if you have a question, feel free to go off mute and ask it.
What types of programs do you guys write?
So I think the question is, what kind of applications maybe do you guys do we work on? Is that the question, Mike?
Yeah. Yes. Yeah.
So I'd mentioned it in the earlier part, some of the things that we're working on POCs, but Siddhant, you could maybe mention a couple of the things that that you've been working on recently that deploy RAG. I guess you
So,
know that you I guess you demoed some at last week's live meetup, right?
yeah. Right now, I've been working on 3 projects, and one of them uses RAG, the latest one. And that project helps people find up-to-date medical research from PubMed API. I get into the PubMed API library so that whatever the user searches, uh, the user gets up-to-date response from the PubMed library, and you also get summaries of the research papers so that it's easier for you to read.
And I guess I'll mention too, as a follow-up, really, Siddhant has been really working on the large language models and using those APIs, and Devin has been working more on local small language models. So we're trying to address each end of that spectrum.
Yeah,
Thanks.
the things they work on, how do those things generate revenue?
So right now, in the lab, we are doing proofs of concepts, and we are not at this particular juncture looking to generate revenue.
So nobody
But
in this group does any type of programs that generate revenue?
so in the applied AI lab right now, we're working on POCs, and our goal is by the end of the year 2025 to see what we can do to partner with government agencies, federal agencies, private industry, small startups, as to how we can help generate revenue there.
Do you have a website?
We do have a website, and I can post that in the chat.
Does anyone do any type of like AI machine learning, object identification, visual recognition of patterns using AI?
Yeah, so that was actually one of the things I benchmarked and showed off last week at the meetup. I found a bunch of these vision models on Olama, and I just kind of gave it a bunch of images, saying like, count how many of this object is in an image. Like for example, Tom at one meetup had a bunch of honey jars, and I asked one of these vision models to count how many honey jars there were. Now they weren't good, but they at least tried. And I also asked it, like, what color is this person's hair, or who is this character from the show, and different things like that. So there are various vision models out there
So
to
one
look at.
example, or two examples. One would be biometrics,
Mm,
very complicated. They can identify a person with the facial features. The other one would
yes.
be, you say something?
Yeah.
Go
Sorry.
ahead. What do you
No,
want to say?
sorry. Continue. My bad.
The other one was the in self-driving cars, they identify objects like another car, bike, pedestrian, cat, dog, whatever, and it labels and it can identify different objects. And I was just wondering if anybody ever worked in any type of application like that.
Um, I don't think we worked on it directly here in the office, but I know that is part of a broader concept called computer vision,
Yeah.
where it looks at various images and it can label them. And so we have not directly worked with image classification yet, but that could be something that we look into in the future.
And
So there's no shortage of ideas for us to work on here in the lab, and we have only so much time, so many resources, and we are picking things that we think are strategic. And right now, our goal is really understand, benchmark a lot of these tools, and then give lunch and learns and try to help people understand what these AI tools and technologies are all about.
so what is your website?
It is c4a.ai. And Devin, you want to throw that into the chat, please?
Yep, I was doing it right now as you were saying it.
Cool, thank you. In order to wrap up, we're about half an hour into this, and we try to wrap up in about 30 minutes so people can get back to their lunch hour. As we mentioned earlier in this talk, the next Lunchbox talk will be in 2 weeks, and it'll be Devin and Siddhan again, and we'll go ahead there and demonstrate the use of RAG, and we'll give a demo or two. I put it in the Slack, in the chat. If you'd like to join our Discord server, you can go ahead and click the link that is in the chat, or you can scan this QR code. Last week we had our third live meetup where Devin, Siddhan, and our other AI engineer, Omo Clark, demonstrated the work that they've been doing this summer. That was a lot of fun, and there was a lot of excitement. So we'll do another technical meetup and networking event probably in late October or into November, and we'll be publishing that when we get it, when we know what those dates are. And then finally, we do have some live course offerings on September 17th, October 24th, October 17th. So we've got a course, 4-hour course, AI for Leaders, and a 4-hour course called Foundations of Modern AI. And you can go to the c4a.ai website to get more information of those. But if you'd like, because you're here at the Lunch and Learn, we're offering a 50% discount for those courses with that code there. So, thank you very much for everyone attending. Devin and Siddhan, thanks a lot for the information, and we look forward to seeing both of you here again in 2 weeks. And thank you everyone for joining.
What do you think
have,
are the greatest,
have a nice day.
Greatest potential of AI? Greatest potentials of AI?
Thank you. All right, everyone, have a great day. Thanks again, Devin and Siddhan.
Thank you, guys. Have a great day.